This is a volcano, this is an eruption, and this is a catastrophe. But what makes the difference between these three pictures is time. The first one we could have predicted, the third one we should have predicted, it's the middle one that we can't, at least not yet. As climate change warms up our planet, it might mean that we'll see more eruptions like this last one. So we're going to need some major improvements in our understanding of volcanoes if we don't want them to catch us by surprise. So let's talk about how scientists do predict volcanic eruptions and why they sometimes get it wrong. Volcanoes are ranked based on how dangerous they are. Not all of them are created equal. Some have been dormant for hundreds or thousands of years, while others are active, erupting regularly or seemingly at random. Others are quietly bubbling along with magma just beneath the surface. These different categories tell us a little bit about what kind of behavior we can expect from each one, but it's not always easy to tell exactly what will happen next. Let's start with the sleeping giants because they offer perhaps the most accessible example of predicting an eruption. A good example is Mount Vesuvius in Italy, which famously blew its top and buried the Roman city of Pompeii in 79 CE. Vesuvius has been quiet since then, or at least it has been quiet compared to its other more active phases. But scientists know that it will wake up again because they can literally feel it getting restless underneath the ground. And they use sensitive instruments called seismographs to listen in to the rumblings beneath the surface. In the case of Vesuvius, scientists are listening out for the telltale signs of magma pushing up from deep within the earth towards the surface. The magma moves through channels known as dikes, and as it does so, it causes seismic waves to radiate outwards from the center of the volcano. Scientists can take that data and model what the magma chambers might look like. But even if scientists aren't able to predict when exactly an eruption will occur, they can use these signals to estimate the likelihood of one occurring in any given year. And the knowledge that there is a magma chamber beneath the surface allows authorities to plan ahead. In fact, there's a whole city worth of people living right in the danger zone of Vesuvius, and their local officials use these predictions to plan evacuation routes and safe zones. So no one expects Vesuvius to erupt tomorrow, but the threat is real enough that they have to plan for it. The same goes for Mount Fuji in Japan. There's a big difference between knowing your house might be destroyed in the next 100 years versus having to pack up and go in the next 100 days. For instance, in Japan, where Mount Fuji looms over Tokyo, the threat posed by the volcano is taken very seriously. About 250,000 people live within the danger zone of the volcano, and many more millions in the wider region. The Japanese government requires residents to take part in annual evacuation drills, and they keep emergency kits ready to go at a moment's notice. Even so, Mount Fuji is a bit of a special case. You see, historically it erupts pretty regularly, blowing its top about every 300 years. So we know it's coming back at some point, but we don't know when. Now would be a good time to study it. Now for something a little more pressing, Mount Ibu in Indonesia. This volcano is highly active and dangerous, and local authorities have had to order evacuations several times in the past decade because of increased activity. In 2021, the Indonesian Center for Volcanology and Geological Hazard Mitigation raised the alert level for Mount Ibu after it began to show signs of unrest. Using continuous GPS monitoring, they observed that the summit of the volcano was slowly inflating, indicating the buildup of pressure from magma below. They also detected an increase in the frequency of small earthquakes beneath the volcano, which is another sign of magma movement. The combination of these factors led the authorities to raise the alert level and order the evacuation of tens of thousands of people who live around the volcano. Luckily, in this case, the eruption wasn't too severe, but it was still significant, sending ash plumes over 3 kilometers into the sky. Although in this case, the eruption didn't pose much of a risk to populated areas, the danger remains. Because Mount Ibu is located near the edge of a tectonic plate, it is constantly reshaping the landscape around it. As it grows, the surrounding terrain is reshaped, creating new valleys and changing the course of nearby rivers. These changes can have a profound impact on the local environment and the communities that live nearby. For instance, Mount Ibu's eruptions can cause lahars, which are fast-moving currents of volcanic debris and water that can travel down river valleys. Lahars can cause massive damage to infrastructure and can bury entire villages. So it's important to understand how Mount Ibu behaves and how its eruptions may affect the surrounding area. By studying Mount Ibu, scientists can develop better models of how it erupts and how its eruptions may affect the surrounding area. This information can help local authorities to make better decisions about how to manage the risks posed by the volcano and protect the people who live nearby. Take, for example, Mount Pinatubo in the Philippines. In 1991, it erupted in a spectacular display of volcanic activity. Ash from the eruption covered an area of 400 square kilometers, forcing the evacuation of 80,000 people. However, there were also smaller eruptions leading up to the main event, which could have been better understood with continuous GPS monitoring. Continuous GPS monitoring of volcanoes can help scientists to identify small movements in the Earth's surface that may indicate the buildup of magma beneath the volcano. This information can be used to develop more accurate models of volcanic activity and improve the accuracy of eruption forecasts. Continuous GPS monitoring can also help scientists to better understand the complex processes that take place beneath the surface of the Earth. By measuring the movement of the Earth's surface over time, scientists can gain insights into the forces that are shaping our planet. GPS technology is already being used to monitor volcanoes in various parts of the world, including Mount Ibu. However, these systems often rely on expensive and specialized equipment. But fortunately, the technology is becoming more affordable and accessible, which means that more volcanoes can be monitored and the accuracy of existing monitoring systems can be improved. So continuous GPS monitoring is not only useful for understanding the behavior of individual volcanoes, but also for developing a better understanding of volcanic activity in general. And finally, I want to talk about what happens when we don't predict a volcanic eruption correctly, which honestly is most of the time. In the case of Mount Unzen in Japan, scientists were unable to predict a massive eruption that occurred in 1792. At the time, there were about 12,000 people living on the island of Shikin, and almost everyone was caught off guard by the sudden eruption. The eruption column reached a height of 24 kilometers into the atmosphere, and the pyroclastic flows destroyed nearly every building on the island. An estimated 2,000 people died as a result of the eruption. So how did a society that understood the power of volcanoes so well get caught off guard? Well, it comes down to the complexity of volcanic activity. Even today we cannot predict when and how a volcano will erupt. And in the 18th century, the tools and knowledge available to scientists were much more limited. There are many factors that can influence the behavior of a volcano, such as the type of magma, the shape of the volcano, and the amount of gas and pressure inside the magma chamber. And interactions between these factors can be incredibly complex and difficult to understand. Despite these challenges, scientists have made significant progress in understanding and predicting volcanic activity. Today, we have advanced tools such as continuous GPS monitoring, which can provide valuable data on the behavior of volcanoes and help us to better understand the risks they pose. You see, although we may never be able to predict volcanic eruptions with 100% accuracy, we can continue to improve our understanding of volcanoes and the risks they pose. By investing in research and technology, we can better protect the people who live near volcanoes and reduce the impact of future eruptions. It's a bit of a balancing act, really. You see, while large-scale eruptions can be catastrophic, they also play an important role in shaping our planet's geology. So predicting them accurately is crucial for protecting lives and property without hindering the natural processes that shape our world. And with more research and development, we may one day be able to strike that balance more effectively. And that's why we do what we do here at SCI Show. We think it's important to understand our world, both the good and the bad. Thanks for coming on this journey with us to explore the science of volcanoes. If you enjoyed this episode, I know you'll love our podcast, CI Show Tangents. In it, our own delve into the weird, wild world of science gone wrong. From disastrous datasets to explosive experiments, each episode is full of fascinating stories of science gone awry. Just like this story about the time a real live volcano interrupted a science experiment. You won't want to miss it. Thanks for watching.